It responds in 4 milliseconds. It delivers 100,000 charge cycles while the battery in your garage dies after 3,000. The lithium-ion battery industry generates $75 billion annually. The entire flywheel market generates $435 million, less than 1%. Not because the technology failed, because you cannot build a subscription model around a device that never needs replacing. This is flywheel energy storage, and this is not a story about suppression by force. This is a story about what happens when one technology quietly fills all available space. The archive opens 8,000 years ago. A potter sits in Mesopotamia. In front of him is a heavy stone disc, roughly 40 kilograms, mounted on a simple wooden spindle driven into packed earth. He kicks it once. The force lasts less than a second, but the stone keeps spinning for minutes. That single moment contains a complete energy system. Human effort is irregular, but the spinning mass smooths it into continuous motion. The potter doesn't know it, but he has built the first flywheel. And this discovery doesn't happen once, it happens everywhere. In ancient China, in Egypt, in the Indus Valley. Every civilization that works clay finds the same principle: store energy in motion. Not chemically, not electrically, kinetically. Physics is universal, and it has not changed in 8,000 years. Fast forward to medieval Europe. Between 1070 and 1125, a Benedictine monk named Theophilus Presbyter compiles a technical manual: metalwork, glassmaking, painting, and hidden inside it, something more important: the first documented use of a flywheel as a general mechanical device. Not just pottery anymore, anything that needs smooth rotation. By 1200 AD, the spinning wheel spread across continents. It transforms textile production. But mechanically, it is still the same idea: a heavy rotating mass storing energy between human inputs. Then comes the Industrial Revolution. Steam engines arrive. They are powerful, but unstable. The piston moves up and down. Energy comes in bursts. Without intervention, the machine stalls. So engineers attach massive flywheels. The piston pushes. The flywheel carries motion through the dead zones. Reciprocating becomes rotating. Rotating powers factories. By 1876, the Centennial engine stands 12 meters tall in Philadelphia, producing over 1 megawatt of power. Its flywheels measure 9 meters in diameter. Industrial civilization now runs on stored rotational energy. But there is a limitation. Flywheels can smooth energy, but they struggle to store it long term. Because of one problem: friction. Every traditional flywheel touches something. Bearings create drag. Drag drains energy. A system that should run for days slows in hours. This is the barrier that holds the technology back for centuries. Now we move to 1946. A Swiss engineer asks a question that sounds absurd: can public transportation run on a spinning mass? The answer becomes the gyrobus, a 1,500 kilogram flywheel spinning at 3,000 RPM, mounted under a passenger bus. No fuel, no combustion engine, just stored motion. By 1953, it runs commercially in Switzerland. Passengers board like any other bus. It stops at charging stations. 3 minutes. The flywheel spins up. The bus drives 6 kilometers. Then repeat. At its peak, 12 gyrobuses operated in the Belgian Congo. They run in tropical heat. No emissions, no fuel dependency. They work every route, every day. By 1959, they were gone. Not because they failed, because diesel wins. Diesel requires no infrastructure, no charging stops, just a tank. The physics didn't lose, convenience won. Today, only one gyrobus remains, preserved in a museum in Antwerp, a working system that simply became unnecessary. Now we jump forward again. Late 1980s, a physicist named Richard F. Post is working inside a national laboratory. Born in 1918. PhD from Stanford in 1951. Spent 63 years at Lawrence Livermore. He helped pioneer nuclear fusion. Then funding collapses. Most scientists retire. He doesn't. At 70 years old, he turns his attention to a forgotten problem. Why can't flywheels store energy longer? The answer is still friction, and his solution is radical. He removes contact entirely. Post develops passive magnetic bearings using a Halbach array. The rotor levitates. No physical contact, no mechanical drag. It spins in a vacuum. No air resistance, no friction, nothing touches it. He keeps a sign in his office. It's the bearings, stupid. With that one insight, he changes everything. Modern flywheels now achieve over 90% efficiency. For the first time in history, long-duration rotational storage becomes viable. Post continues working into his 90s, still filing patents, still experimenting, still curious. He died in 2015 at age 96. A colleague describes him as like a kid in a candy store. In 2011, Beacon Power went bankrupt. The flywheels continue operating, the company does not. Now Howard Leong, founder of Key Energy in Sydney. In 2023, he installed something almost unheard of, a residential flywheel system. Location: Western Australia. Capacity: 32 kilowatt hours. Weight: 5 tons. It stores a full day of household electricity. No fire risk, no degradation. Expected lifespan: decades, possibly longer than the home itself. Meanwhile, in 2024, China has the world's largest flywheel installation. 30 megawatts, 120 magnetic levitation units. Single project. The United States: 2 grid-scale flywheel plants, built over 10 years ago, still operational, never expanded. Now compare the scale. Tesla signs $6.4 billion in battery supply contracts in 2025. That is 14 times the entire global flywheel market. Tesla and Enphase control 92% of the US residential battery market. Nearly half of all new solar systems include batteries. This is not a competition. This is infrastructure momentum. Training programs teach batteries. Installers install batteries. Standards certify batteries. Appraisers value batteries. Flywheels? Technically allowed. Practically invisible. And this is where the narrative shifts. Because no one banned flywheels. No law prohibits them. They simply never became the default. Now this is the part they will not tell you. They will not tell you that a flywheel plant in New York has been running since 2011 with 99% reliability. They will not tell you that China deployed the largest flywheel system in the world in 2024. They will not tell you that a family in Western Australia stores energy in a 5-ton spinning mass that may never need replacement. They will not tell you that flywheels can cycle 100,000 times without degradation. They will not tell you that this technology is older than written language, because none of that supports a system built on replacement. A potter in Mesopotamia discovered that a spinning disk stores energy. That principle has never failed. It has only been ignored. If this changed the way you see energy, hit like and subscribe so you don't miss what comes next.